This is page 3 of the review. Problem number 7 asks to find the value of x in each of the figures below. Here, angle x is adjacent to this 49 1/10 degree angle, and together they form a right angle. These rays are perpendicular, and so these are complementary angles. The 49 1/10 degree angle plus x will equal a sum of 90 degrees, and so we can just subtract 49 1/10 from both sides of this equation. Line up a decimal in our difference, and we get x is equal to 40 9/10. I would add that back to 49 1/10 just to make sure. That's 89 wholes and 10/10, which makes 90 whole degrees. This drawing is showing you a reflex angle of 290 degrees, and you're asked to find the value of x, which would be this angle, which looks acute. We'll know in a minute, but we know that the relationship here is that these two angles form a full circle, so we're going to subtract that 290 from 360 in this case. So that is acute. It's a 70 degree angle. Here we have this acute angle 19.2 degrees and this obtuse angle x. They're adjacent and they're on a line, so they're forming a straight angle. They're supplementary, so we can subtract the 19.2 from 180. Get 160.8. If I add that back to 19.2, I get 179 and one more whole, so 180. So that looks right, 160 8/10 degrees. Problem number 8. Again, we have more angle relationships. We're trying to find missing angles. Here we see that these two sides of this quadrilateral are perpendicular, so this is a 90 degree angle. Also, it has the square 90 degree angle symbol there. And so we know that all of the angles of any quadrilateral add up to 360. So the expression I'm going to use here to find the missing angle will be 360 minus the sum of the three angles we know. So that's 360 minus I'm just going to do this. It's actually easier if I think of it this way: 160 and 50, because I can subtract the 160 gives me 200. I subtract the 50 from 200, I get 150 degrees. And then it's always good to add them back together to make sure they actually add up to 360. The 150 and the 50 is 200. These two add up to 160, so that is 360 degrees. The sum of the angles of any triangle, remember when we tore the corners off of a triangle and placed them adjacent to each other, they formed a straight angle or straight line. So we know that some of the angles of a triangle is 180 degrees. So I'm going to use the same method, but starting with 180 minus the two angles I know, 23 plus 141. This is 180 minus 164. What would you add to 164 to give you 180? 16 degrees. That looks reasonable. That's a pretty small angle there. Problem number 9 says a rectangle has a perimeter of 2 meters and a length of 70 centimeters. What is the area of the rectangle? The tricky thing here is we have one of the measurements in meters and the other in centimeters. So I'm just going to convert these 2 meters to centimeters. If you recall, you have base units, then you have decimeters, then you have centimeters. Or if you just know that there's 100 centimeters in a meter, you're going to go from meters to centimeters. You're going to move your decimal 2 places to the right, the same as multiplying by 100. So 2 to the right will tell me that this perimeter is 200 centimeters. Now they're talking about a rectangle, but they're not showing me the rectangle, so of course I want to draw myself a rectangle so I can better visualize this problem. We know the length is 70 centimeters. And so I don't know I'm trying to find the area. If I could find the height or the width, then I can find the area. I know that the 200 is the sum of all the sides. So far the sum of these two sides is 140. So 200 minus 140 is 60. Which doesn't mean this side is 60, it means it's half of that. So if this is 30 and this is 30, then you can see if you add this and this base and this height, you have 100, and then you have the other 100 here. So these must be 30. So the area will be base times height, or 70 times 30. 70 multiplied by 30, you could just think of it as 7 multiplied by 3 multiplied by 10 multiplied by 10, which is just 100. So 2100, 2100 centimeters squared. If you did it, if you did everything in terms of meters, each of these would look like this, and then you would get a area of 0.21 meters squared, or 2100ths meters squared. Calculate the shaded area below. There's different ways to do this. I think in this case, the way this dimension is shown, you can almost sort of visualize this triangle. I'll call this area 1. This other little triangle here, area 2. And this big rectangle, area 3. So I have area 1 is 1/2 base times height. I'm going to call this the base. So area of shape 1 is 1/2 of 15 multiplied by 10. I'm going to associate and multiply these together first. So half of 150, which is 75 inches squared. Area of shape 2, also a triangle, 1/2 base times height. 1/2 of 5, this base multiplied by this height, which is equal to this height, 10. So that's half of 50, or 25. Area 3 is base times height because it's a rectangle. And the base is 30, the height is 15. So area of shape 3 is 450. The total area is area 1 plus area 2 plus area 3. Or 75 and 25 and 450. This is 100, so 100 and 450 is 550 units, inches squared. This area of this, it's actually a hexagon, believe it or not. It's a concave hexagon because there are 1, 2, 3, 4, 5, 6 sides, so it's a hexagon, but it does have some reflex angles. That's not what I should have marked. Excuse me. I should be considering the interior angles. This interior angle is not reflex. This is 90, this is 90. But this interior angle right here is reflex, as is this one. So this is a concave hexagon. You're not asked that, but I just thought I'd mention it. And since a hexagon this hexagon is a piece of this plane, and a plane is 2 dimensions, that's why it's inches squared, inches to the 2nd power. It literally means if I had 1 by 1 inch squares, there 550 of them would fit inside of this space. Okay, that completes page 3. We'll pick up the review with page 4 on the next video. Thanks for watching.